of a constituents, if I could actually say, of Botanic Gardens. I have so many Botanic Garden members and partners that I can't show you all the wonderful things that they're doing. So I'm going to give you an overview of the support that Botanic Gardens provide and a taster. And I do hope, if you have questions or want to contact us on your region, your country, a local Botanic Garden, please feel free to contact me. So let me start by saying, what is a Botanic Garden? So we have a definition. It's an institute holding documented collections of living plants for the purposes of scientific research, display, conservation, and education. And there's so much that goes on under those four areas: scientific research, display, conservation, education. And today, because we're going to focus in on 4.4 of the GSAP, we're going to look at the scientific research and the conservation. Of course, there's display and education, and that's also vital, but it's the ex-situ plants that need to be saved, cultivated, bred, and then put into in-situ conservation actions. And that's what I'll focus on today. So who's Botanic Gardens Conservation International? As I've said, we're a network organization. We are the biggest plant conservation globally. We represent about 3,500 institutes. We have 950 Botanic Garden members. And on screen, you can see what we've got there is the map of Botanic Gardens, of registered Botanic Gardens globally. And of course, we've positioned those in their countries of where they occur according to biodiversity hotspots. So the pink shaded areas on the various continents. And you can see there are Botanic Gardens in those hotspots. And there's those that are also outside. And all of them are contributing to the conservation of threatened plant species. So what we have in our Botanic Gardens, and we did a study a couple of years ago, and we actually are busy now revisiting that work. So we know we have approximately 30% of the world's plants in our living collections, in our ex-situ collections globally. And as I said, it's a registered Botanic Garden. So it has to keep provenance of where these species come from. It has to have accession records, de-accession records, a database. For many of you in the aquarium, the zoo's environment, a stud book, but for plants. Which is a strange thing, but we have those. And what we know from the study previously is that we have about 40% of threatened plant species in our living collections. It's not great, but it's not nothing either. And we are using those species in the collections for conservation. So the term conservation horticulture is what we do in Botanic Gardens. There is horticulture, there's garden horticulture, there's landscape horticulture, but we are Botanic Garden conservation horticulture. And we ensure that we have genetically diverse and representative populations of wild plant species. We have plant material that we are using for the in-situ conservation, for population reinforcement, reintroductions, repatriation, whatever term you want to use in your country, as I know the terms are used differently, but it's the in-situ conservation of wild populations and reintroductions. And then supporting education and environmental sensitization, letting everyone know that we need to save the habitats and the species particular to those habitats. And these are the plants. And it might just be the plant that a particularly threatened animal eats, but we need to save them as well. So where we've seen successes in our Botanic Gardens is that we have approximately 116 plant species extinct. That's not a success of a Botanic Garden. That's a failure of us as people. Some directly people related, human intervention, others not. But what we do have and what we know is that we have 36 plant species that are recorded as extinct in the wild, but are in cultivation in our Botanic Gardens. And these ones are vital. They've been lost from the wild, and we have our Botanic Gardens working with these species and getting them back in the wild, back into their original habitats, or close enough where some habitats have been completely lost. And I have numerous examples for these 36 species, which I don't have the time, sadly, to touch on these. But what I can give you now is an example of probably one of the loneliest plants in the world, Encephalatus woodii. It's a cycad from my home country, South Africa. It's extinct in the wild. Last two remaining stems from the 1900s. There's a picture on the left of the screen there that, that's it. And numerous field trips are still taking place to see if maybe we could just find one or two. What we do have in the Durban Botanic Garden is the original plant that was collected from the wild and planted in the garden when we still had them in the wild and they weren't extinct. And then we have examples around the world. We have 500 individuals in botanic gardens globally that are representative of this species. And we know, in Fairchild Botanic Garden in the USA, they're doing tremendous work to propagate the species, to duplicate it. Now, the problem here is you need male and female cycads in order to get seed, and sadly, we don't have males and females. So, numerous research is taking place to look for these species, but we do have other success stories of where species are extinct in the wild, they've been reintroduced, some are approaching their third generation, which is requirements for them to be self-sustaining and grow and propagate and maybe be reduced and not be extinct in the wild anymore. They'll be critically endangered, but they're not extinct in the wild. So I'll go into the second part of my talk. So that's the application, the living collections, the conservation of those species in botanic gardens. But how do we know? What are the species we need to be saving? Botanic gardens aren't big enough to have the world's flora in their glass houses and in their nurseries. So we're assisting with the red listing of plants. And at BGCI, our focus has been on tree species. But we do assist other groups with red listing of other plant species within the IUCN SSC specialist groups and others. We're not biased. We're going to support any plant species that needs to be saved. And red listing is the start. It's the prioritization of the mechanism that we need to put into place to save these species. So for the trees, we started with taxonomic groups, Northophagus, Magnolia, and they're listed on the screen. And we also looked at regional groups, and we looked at the different reports. And we said, you know what, we need a global collaboration. We need to red list all the world's trees. So we started this, and I'm pleased to say that we're approaching about 96%. We do have the first fully comprehensive list of trees on the IUCN Red List as of now. And it's not just BGCI. We have collaborated, and this is, our botanic garden community, our experts, our taxonomists, over 100 institutional partners coming together to red list tree species. And yeah, over 1,000 experts involved globally. In 2021, we published State of the World's Trees when we were about halfway, and it had a major impact. It highlighted the threats to trees, sentinel species for not only flora, but fauna as well. And it just really showed the world that we need to take action. We continued with this report, and from what we had on that report, we found that we now know that at least 30% of the world's tree species are at risk of extinction. 142 species are extinct in the wild, and we're still looking for those. Maybe there's one or two remnants, and we do have some in our botanic gardens. But what we do know is that twice as many trees are threatened as mammals, birds, amphibians, and reptiles all combined. And that's a huge group. We know which ones are threatened, we know which ones could be threatened, and we know where to prioritize our actions. So we went a step further to help governments decide which tree species they needed to look at. So we listed the number of species per country, and then went and had a look at globally threatened species per country to help individual countries take action and put it in their NBSAPs and put it in their national species recovery plans, which trees they need to work on. We also had a look at where the greatest threats to trees are, so we can look at mitigating and combating those threats. Agriculture came out tops, with logging and livestock farming coming in. Land use change is there, but interestingly enough, climate change is the least threatening of tree species at this stage. As we've continued since 2021 with the red listing, climate change is coming more as a factor, as it's being added to the red list, particularly for plant species because they can't migrate, they can't move. Their evolution is slow. So climate change is moving up the forest as such. We then had a look at a particular group of trees and tree species. And this is in 2022, we looked at the Red List of Timber Trees. And it was part of the Barometer of Life project. And we looked at 4,000 timber assessments completed. But why timbers particularly? When there's so many other threatened trees and use, and they were not comprehensively assessed. There's some assessments that are controversial. They have economic importance, they have spiritual importance, they have ecosystem importance. So we used this group, and it's a particular focus, timber trees, CITES listed timbers, legumes and dipterocarp. So we had a look at that. And what we found for timber particularly is that about 5,000 timbers have been assessed. 34%, so it's higher than the global average for all trees, are threatened. 5 are extinct due to use for timber, and 45% are having a population decline. And as I say, we're revisiting this and we're working with groups like CITES for individual species to have a look at how can we use them sustainably, but ensure that we're not losing them to extinction. So bringing us back to the full, we have the ex-situ and the in-situ conservation. And if we have a look now that we've red listed the timber trees, and we have a look at what do we have in our ex-situ collections for timber species, you can see that we don't have many critically endangered or vulnerable species. And, we really need to get those into our collections just in case we need them in case of a catastrophe, pardon me. But if we have a look at in situ, we can see that a lot of these tree species are indeed protected in a protected area. There are others that aren't in protected areas. So now we can actually focus with all of this information, using our botanic garden knowledge, secure them in our ex situ collections, get them into in situ, have them protected, and having countries focus on their threatened species, all coming together to save our environment, our species, our fauna, and our flora. Thank you, David. That's the end of my quick run through. I could spend hours doing this, but we have other important speakers, and I'm happy to give the time over to them. I can't hear you, David. Are you on mute?
Can you believe it? All this time. Thank you, Carly. Thank you for the talk. That was amazing. I had the pleasure, and it really was the pleasure of going through that global tree assessment and being taken through it. It is remarkable, and how that's worked to translate it into so many of all those ex-situ priorities and strategies. So brilliant stuff. Thank you so much. There will be immense amount of questions, I really am sure. So please put them into the Q&A function, and we will get through as many of them as we can at the end of all the talks. So now we move from flora to fauna to some talks from Dr. Andre Stadler, who is the director of the Alpen Zoo in Innsbruck. Are you with us, Andre? I can't see you on screen just yet. Oh, good.
I'm here, but Megan turned off my camera and I can't turn it on. So believe me, I'm here.
Well, as long as you're here and we can see your slides, that will be fine. There we are. Fantastic. Fantastic. Andre is going to talk to us about many of the work that's going on in that amazing zoo in Innsbruck. The zoo has recently opened the Centre for Species Survival for Small Mammals, and it's renowned for its conservation work with alpine species. Andre, amongst many of his roles, is also a colleague on WASA Council, but he's going to talk to us today about the ex-situ breeding programs with a spotlight on an incredible species, the Bavarian pine vole. Andre, over to you.
So thank you for the kind introduction, David, and good afternoon from a rainy Innsbruck. So I don't have the luck with the weather today, but I have luck that I can present you a little bit of our conservation program of this Bavarian pine vole, which you can see here now. It's one of the most endangered mammals of Europe, or as I told it, it's one of the most endangered mammals of the world, because in a very optimistic point of view, there are 100 left. But I want to start my talk with first thanking my colleague, which is in the top right corner. This is Nora Weyer, which is a colleague of mine, and she put together all these slides, and she's doing a tremendous work in saving the species. So a big thank you to her for helping me in giving this speech. Where are we in the world? We are in Central Europe. We are in the Alpine region, and the red dots are the only localities where the species occurs. As mentioned before, it's one of the really critically endangered species, and you can only see two dots. These are the only places in the world where the species occurs, and the next related species are in the Southern Alps. We're in Central Europe, we're in the Alpine region, and they are only in the northern part, and the next closely related species are in the southern part. This is how it looks like where the species occurs. This is a picture from Germany. This is Garmisch-Partenkirchen. And this is a locality where the species was described in 1962, because the species is it's known to the humankind only 60 years ago, and then directly vanished for 60 years, and nobody has seen them again. Where do they live? They live in these grassy areas next to the forest under these roots. And from these roots, they go out on these grassy areas for every 2 hours, and then they disappeared under the ground again because they're subterranean, mostly night active animals. What we want to do in our conservation program is we want to enabling the survival and improving the status of the species, both ex situ and in situ. So we want to establish a breeding program in Europe. And as nothing at all is known about the species, we want to collect and publish as many biological data about the species, about their communication, their behavior, physiology, how many babies do they get, what do they eat, etc., because, as mentioned before, we don't nothing at all. But on the other side, we want to monitor the two sites where the species occurs, what is happening with this species, because this started before the Alpenzoo has started its conservation program. And in all the reports, you could read, hey, there are 100 left. Hey, there are 70 left. Hey, there are 50 left. So the population is going down and nobody's knowing why. On the other hand, we want to make the species more famous. It's a little bit telling the underdog story, because saving tigers, saving pandas is very important, but nobody is taking care about these little creatures living on the ground, about rodents, etc. So, for example, we had a 45-minute TV show about this species, or we're selling swags, hoodies, etc., about these Bavarian pine woods, and they're already 4 times sold out. So we managed to make the species more famous. And in a long-term point of view, we want, of course, protect the natural habitat and, if possible, reintroduce, if possible, the species back to the wild or to suitable habitats, all following the IUCN guidelines. What has happened so far? We get the allowance in a fire rescue action to bring in some animals to our zoo. So they first went to our quarantine station. From there, we had the first enclosures, because this species was never kept before in human care. So we had to start from the scratch. We didn't know anything at all about how to keep them. But after a while, we saw the animals are going very well in captivity. So we improved our enclosures. This is how it looks like nowadays. And after 4 years, we had some great successes. In total, we had 60 offsprings in total. And at the moment, there are 30 individuals living in some zoos in Europe. And the Zoo of David is one of the next joining us in this situation, because I didn't want to have all the animals in my zoo, because if there's any disease popping up or whatever, they would disappear from the ex-situ world again. So I started very fast to spread them over several zoos, and this is the current population you can see at the moment. We know nowadays how to catch them, we know how to sex them, we know how to transport them, and our goal of documentation as many biological data as possible is going on now for 4 years. Of course, my veterinarians had fun with the species as well after 4 years. This is kind of a cute picture of a Bavarian pine wall in a CT scan. So we know how to treat these animals as well. And the successes were we managed to keep the species for 4 years. We increased the population. We have the first research outputs. We know the nesting building behavior, which was not known before. We know the gestation periods, the litter size, the activity patterns, the communication. And also we started to publish this data also on a scientific point of view and in the wider public area. To the left is an article for National Geographic. They came over to our zoo to make some pictures. In the middle, you see a poster we gave at the VASA conference about the communication. And to the right, you see some studies done by my students about the surface activity of the Bavarian pine woods. So you can see our goal about collecting data and publishing is quite successful. And then we had the great chance last year, together with the IUCN Small Mammal Group, to establish an IUCN Center for Species Survival, which were the 19th in the world at this moment. So we managed to bring us to the next level. Now we have this IUCN Center, and we are not just taking care about rodents and alpine species. Now it's on a global scale, and Nora is not only taking care about Bavarian pine woods, she's organizing now the Center for Species Survival together with a small mammal group to save the small mammals in general, which are a little bit underdogs, but are 3,000 species in total. So we really should take care about them. And to the right, you see a picture, me smiling really brightly, because at that moment we were funded by the European Union for the conservation program of the Bavarian pine wall, and we got money to make even much more for the conservation. The next steps for us at the moment are to establish an on-show enclosure that the visitors coming to my zoo can see the species, to further evaluate and improve the keeping in Hasbury, of course. And on the in-situ side, we will continue and expand our monitoring. The field season just started yesterday. So the colleagues went out yesterday. You can see this brand actual picture from them from yesterday. We want to monitor the sites. We want to make live trapping. And this will all end in a species distribution modeling. We don't understand the species, as mentioned before, because the two localities where they occur are completely different. The only common thing is that there's a small river, but all the other things look very different. So we have to do field scouting, etc., etc. We want to expand our research, for example, on bioacoustics and communication, parasites, reproduction management. Let's talk about AI. And we have some new topics, ex-situ and in-situ pathology. And for monitoring in the wild, we are starting a program with eDNA, so which will be much easier instead of bringing in camera traps, taking samples in the wild. And if we have DNA, we can say, hey, the species is here. We want to increase the public awareness. We are 4 times sold out with the merchandising, but I want to be 10 times sold out. So the media interaction will increase. The outreach to schools, landowners, and general publics needs to be increased. And we will start information campaigns on the field sites. And you can see it's not so easy where the species occurs. These are pictures from Innsbruck area. So we had snow till 2 weeks ago. And of course, we cannot make this alone. We are very grateful to this bunch of our colleagues and partners and supporters. And yeah, we are on a really good way, but it's kind of a marathon. It's not a sprint. But I'm very proud that I could present it to you now, and that you hopefully know all fans of these lovely species. And I feel free to ask me all the questions. These are our contact details, but we will have our session later on. And I really stick to my time, David. You were worried that I'm talking too long. So I manage my time. Thank you for your attention.
Fantastic, Andre. And quite genuinely, I could listen to that for almost forever. It truly is incredible. You know, for these projects to succeed, it requires innovation. And you and Nora have shown that innovation to that success. And your last slide showed the importance of collaboration. And I am absolutely delighted that our zoo here at Edinburgh is going to be part and parcel of this project because you've inspired us. You and Nora have inspired us to be part of that collaboration. So it's amazing, amazing work. Congratulations for this wonderful Bavarian pine ball.
Thank you. We're just at the start at the moment, but I'm quite optimistic.
It's congratulations. It's tremendous. It's tremendous.
Thank you.
So from a tiny little pine vole to one of the most majestic birds of the skies, one of probably the most iconic birds, iconic stories that we've had around bird recovery is the Californian condor. And it is amazing to have, we are very lucky to have Dr. Nacho Vilches, who is the Associate Director of Recovery Ecology at the San Diego Wildlife Alliance, to tell us about this project of the Californian condors. Nacho, your experience with seabirds, raptors, and ecological restoration goes before you, but this is a high profile, such a long recovery program. We're delighted to have you here and looking forward to your talk. Nacho.
Thank you so much. Thank you so much for having me, and good morning from San Diego. It's early morning right here. And thank you for listening. Can anybody see my screen?
Not yet, Nacho.
How's that?
I'm not seeing it yet.
Let me do that straight. I think Megan asked me to share my screen and I clicked yes, but I'll.
I think Megan and Lois may be able to help if not.
Now we're cooking.
Success.
Well, so like I said, thank you so much. And I'll just start by telling you that, as you all know, recovering Astropaetus species requires huge collaborative efforts among multiple partners. And for this talk, I'm going to give a brief history of the California condor recovery and all its key players. And I'm also going to describe some of them, just the main translocation efforts we have done and continue doing so. And then focus on 5 main lessons we have learned during the last 20 or 30 years of translocating condors. So this map shows the historical range of California condors. They range from British Columbia to Baja California. In 1806, Lewis and Clark reported seeing condors at the mouth of the Columbia River and even shot one for their collection. Back then, folks used to shoot a lot more birds for collecting for museum specimens. And condors were sighting in Baja California up to 1937. By 1950, however, they were restricted to a small wishbone shape of mountains just north of Los Angeles. And by 1981, California condors were down to just 25 individuals in the wild. And in 1887, the very difficult decision was made to trap all these condors and brought into captivity. This picture shows Pete Bloom using a pit trap to capture the famous condor AC9. AC means, for adult condor, and number 9. The last California condor to be brought into captivity, which is a very polemic. And this bird was then taken to the San Diego Zoo Safari Park Condor breeding facility, which it looks a little bit like this. This is an example of one of the several breeding pens at the San Diego Zoo Safari Park, part of the San Diego Zoo Wildlife Alliance. And at the time, only the San Diego Zoo and the Los Angeles Zoo were the only 2 zoos breeding California condors. Since then, the Peregrine Fund and the Oregon Zoo later joined. And just recently, the Chapultepec Zoo in Mexico City joined as well as a breeding center. Now, by 1988, the first captive bred condors were hatched at the Safari Park and then at other sites too. Initially, to have a higher output of eggs and chicks, conservation breeding centers induce pairs to mate a second time and even a third time, like double clutching or triple clutching, by taking newly laid eggs from nesting condors and enticing them to rebreed. But this is really labor intensive and entailed raising condors by wearing condor puppets to underhands behind screens to avoid chicks from imprinting on the keepers. And the consensus now is that having parents raise their own chicks or fostering chicks is much better option for the chicks in the long run. There's even research showing that a parent reared chick does much better in the wild than a puppet reared chick. But puppet rearing is still used when parents are not able to raise their own chicks for any reason. And currently, just about 50 or 55 chicks are hatched in conservation breeding centers in California, and Mexico City, to be released later into the inter-release sites. So after 1987, California condors were extinct in the wild for 5 years until 1992, when the first 8 captive rear birds were released in Bitter Creek, California. So that was the first release site. The second release site was the second introduction site was established in 1996 in the Vermilion Cliffs in Arizona. The third in Central California in 1997. The fourth in Northern California in 2002, and the fifth in Pinnacles National Monument in central, just east of Big Sur, in Pinnacles National Monument in 2003. And finally, in 2022, there's an experimental release site established in Northern California. It's not shown in this map, but if you go just a few, couple hundred kilometers north on the border of California and Oregon, that is where that release site is. Now I'm going to move on to some of the lessons we have learned. The first one is that given time and persistence, these translocations do work. This is an example of the Baja California release site history of releases with ongoing efforts now for 23 years. So a total of 63 birds have been released in those 23 years, and just about half of them, 32, are still free flying. 8 failed to adjust to the wild and were returned to zoos, and 23 perished in the wild due to predation or other events. But most importantly, all the birds that are initially released have now become parents, and there's about 6 to 8 breeding pairs that have produced just 22 wild hatches. So there's a total of 50 now birds free flying in Baja California, which is huge because this population, which there's a border, the birds that we release it's tougher to bring birds into Mexico, and it's the release site that has received the less birds, but yet has produced the most wild hatches as a function of a breeding pair. So they're doing great. Another lesson we have learned is that lead poisoning is still a huge problem. It is the leading cause of death for free-flying condors. The culprit is contamination by lead bullets and carcasses left behind from hunting. So these pictures illustrate the hundreds of small pieces of lead that explode when a lead bullet hits a target. And this radiograph shows how these pieces of lead can spread over, and this example of a deer, all over its body, even when it was shot in the chest. So a hunter can inadvertently leave a contaminated carcass in the wild for their carrion, like eaters and scavengers like condors to get lead poisoning, and even the main hunter can also get poisoned when they take some of this meat home. So this is why there's a huge effort in California and Arizona to advocate for the use of copper bullets. The third lesson has to do with persistent organic contaminants, or POCs, that make way into terrestrial food webs from the ocean. So following the food source I was talking about, before, the terrestrial food source. So although there's a historical and abundant food source in the marine food web, marine mammals can accumulate contaminants such as DDT metabolates that get bioaccumulated as they make their way up the food chain. And this has been documented to affect eggshell thickness in condors from Central California. And thankfully, not detrimentally, but enough that we can measure the difference between birds of the same flock that feed on sea lions and those that do not, that fed on terrestrial food sources. In Baja California, as the population grows and expands, condors here are also venturing into the coast in search of food, just like in Central California. Fortunately, here, the contaminant load in marine mammal carcasses is much, much less than would exist in Central California. The fourth lesson I want to mention is that mentorship is paramount for condor translocations to succeed. Released condors need mentors from whom to learn how to be a wild condor. In this video shows the typical soaring behavior of a California condor. In this example, if this condor, for example, lands at this cliff edge to feed, it has to take into account how much it can eat so that it can still take off. Just like a plane can't take off if its cargo load exceeds its wing loading. And these are things condors have to learn. And this camera trap caught this scenario where a bobcat seen here jumped on a condor that was eating, that was either not close enough to the edge for a quick jump off, or ate too much and was too heavy for a running takeoff. And you can see here how this condor, there's a before and after shot, and you can see how this condor lost almost all of its tail feathers. So the take-home message here is that condors are really, really social birds, and they need good examples from adult mentors to learn how to survive in the wild. And that is one huge lesson we have learned. A fifth lesson I want to talk about is condor movement. So these maps show the ranges, the home ranges of the Central California flock on the left, the range of the Southern California flock on the middle, and it shows the movement of one bird from the Baja California flock on the right. I know, and I want to illustrate that condors can travel long, long distances in search for food. For example, the figure on the right shows the movement of one bird in 2007 that was in Baja California, ventured its way into the United States, crossed the border, and then came back to Baja California. But even with these ranges, these long distances they can travel, the ranges birds do not show are not seem to showing these traveling leaps in California. Their ranges are expanding naturally, slowly and surely, but there's a lot less intermixing that what we expect, especially between the Central California flock and the Southern California flock, which are the two maps on the left. And then the last lesson I want to go and also conclude with this is that we are on the right track. We started with 22 birds, and now the total population is over 570, with 375 of those in the wild. So, given the time and effort, if we continue, we will be able to remove this bird from the endangered list and hopefully work ourselves out of our job. Thank you so much.
Nacho, I'm kind of speechless. That last slide just encapsulates the incredible success, the value of that long-term commitment, and to reverse the decline of species requires long-term commitment that's there. I also love the mentorship. Just beautiful, absolutely beautiful. Now, look, we want to get to the questions very quickly. So I'm just going to make a couple of comments and then I'll hand over to Luis for the question and answer session. I think thank you to all the speakers. Amazing. I think what we've shown here is that ex-situ efforts, whether it's zoos, aquariums, botanical gardens, they aren't just a nice to have. They aren't just supportive. These are fundamental, essential components of species recovery. But I think what we've also seen is that, and the importance that ex-situ conservation must remain tightly connected to broader biodiversity goals. Together, we really can reverse the decline of species. Thank you all for joining. On my behalf, thank you for all of the speakers. Thank you for your commitment, and together we really can reverse the red. So, Luis, over to you, because I've seen some amazing questions coming through.
Thank you very much. Thank you, David. And indeed, very inspiring presentations. We now have some questions that have been asked. We will start with one for Carly on the biggest challenges for botanic gardens to increase holding management and collaboration to save threatened plants, and also whether selection for captivity is a concern for ex-situ plant programs. So I will turn to Carly to answer that one if she's available.
Thank you. Yeah, I think to start, the biggest challenge for our botanic gardens with their ex-situ collections is often space. We do need, but it's static space. As I say, our plants don't roam around too much, thankfully. So we do need that static space. But it's also looking at, and address the genetics, we do need to actually look at different genetics, different populations, bringing them in. And what we're doing is looking at different meta collections in different botanic gardens, holding these meta collections rather than one garden all in one basket. And I think, Andre, you said that about looking at the voles. You didn't want them all in one place in case disease broke out. So, we do the same thing in our botanic gardens. What we're also seeing is a challenge right now is we don't have enough conservation horticulturalists coming through the system to actually work on these species and grow them and care for them, and then advise the in situ placement and care going out into the wild. So we are really working at building the capacity within our gardens and then talking to universities to get more of the youngsters coming in and studying horticulture, and telling them that conservation horticulture exists, not sort of pretty roses in Mrs. Jones' garden, or something like that. So, which is not a problem, and I love roses, but yeah, conservation horticulture is something else. Uh, and yeah, we certainly have to look at our genetics. It's the same consideration as the zoos are taking into account. So thank you for those questions and thank you for listening.
Thank you, Carly. I have a couple of questions for Andre on the Bavarian pine wall, especially on the balance of maintaining genetic diversity with small populations. And I think that's also one of the questions that is going to be asked, that we're asking also for the condors. And also if you have encountered any unexpected behavioral or ecological traits in captivity that could impact reintroduction. So Andre, I don't know if you're happy to answer those questions.
Yes, of course. Thank you for the questions. And yeah, it's a difficult topic. You can only work with what you have. If the species is so rare and we don't know why the species is so rare, and then our catching success was very low. The 2 years after we were successful in catching 3 individuals, we started with 3 individuals. The next 2 years, we didn't find any wall at all. So the species is really rare and we can only work what we have. Yes, of course. In a perfect world, we have a founder basis with starting with 100 animals and make a big genetic diversity. It's more ethical question. And yeah, I'm citing a very famous biologist, and he once told me, if you have one male and one female, you can save the species. It's not perfect, but you can try it. And what we have seen with the Californian condors, thank you, Nacho, it's working. You didn't have a great genetic basis at all. And what was it, 500 flying in the wild or whatever? So it can work. So we have to try it. We try our best. We have our field season started. Of course, we want to increase genetic diversity in the future, if possible. But if not, yes, that's all we have. But I'm optimistic that this species is simply overseen. It's nocturnal, it's subterranean, and nobody's taking a care about underdogs. So I believe there are more Bavarian pine voles in the wilds that we can increase the genetic diversity in the population we have in human care. But at the moment, we're trying our best. As pragmatic as I am in this situation.
Thank you, Andre. We appreciate that. That's certainly a very important perspective. And we also have a couple of questions for Nacho. One of them was about the considerations that were taken into account on deciding release sites for the California condor, and another one that was exactly the same on how does the San Diego's Wildlife Alliance manage the genetic diversity of condors when starting with a small population? Nacho?
Well, yeah. So I think for the first question about how to select release sites, I think when folks, the folks who do that, there's the Ventana Wildlife Society, there's the Peregrine Fund, there's us, there's CONAMP in Mexico. There's lots of there's a Fish and Wildlife Service, so a lot of key players, a lot of work that many people do, and I'm just encapsulating their work here. But if you can imagine what the carcass landscape looked in California 300 years ago, it's a lot different what is now. You have a lot more open spaces that were just peppered with large carcasses of big big terrestrial animals and marine animals in it goes too. For example, elk and deer, a lot more of that. So that is now more secluded into certain spots of California, and so those are the areas where in the mountains where the release sites are focused on. And for the genetic management question, genetic management is a huge component of the release of the Condor Recovery Program, and that's one of the components that the San Diego Zoo Wildlife Alliance manages. Thankfully, because we did start with 22, we know we have a very detailed stud book, so we know. I think this is maybe the only species that we know exactly who and what came from where, and we are able to manage. There's a specialist who manages the mean kinship of all breeding pairs. So whenever breeding pairs are or adults are paired for breeding, they know what mean kinship they want, so that there's equal representation of the three genetic clans that were remaining in those 22 birds. Because that's the goal, is to have as diverse representation of all of the genetic diversity that we had when there was 22 birds, and that genetic diversity is included in all release sites equally.
Thank you very much, Nacho. I see a lot of questions in the Q&A, and thanks so much for all of that. Unfortunately, we're not going to be able to answer all of them, but I'm sure you can reach out to our speakers after the webinar if there are pressing ones. I would like to conclude with one question for David, taking his expertise, taking advantage of his expertise. And it's sort of a broader question that was asking in the Q&A, and is about what can ex-situ institutions, so zoos, aquariums, and obviously botanic gardens as well, can do to better support the action 4.4 of the GSAP. Is it about doing more? Is it about doing better? So if David, you have any thoughts on this, I think that would be really valuable for our audience.
Sure. Okay. Big question. Well, yes, we need to do more. We need to do better. But I think the word that comes to mind is collaborate, collaborate, collaborate. There is an immense amount of expertise, experience, and there may not be that amount of resource that we need out there, but together we can bring resource and use it effectively. Within Reverse the Red, we are working very intensively around the species pledge, for instance, and I would urge people to go to look to the species pledge, because that's how we're bringing together people to set their goals, their real impact goals for what they're doing for species, but getting to know who's working on what and where. It's amazing, even in the same country, people don't know they're working on the same species, and to what, and almost to different ends. And then from there, actually becoming more and more involved with your country and BSAPs, and being participative within that. But from today, species pledge, please. Go provide your species pledge, because that means that we can do more and we can be more effective. And I'm going to say it, we can reverse the red.
Thank you, David. I think we have a lot of still questions, so it's great that it's triggering so much conversation. All of that, unfortunately, I'm really mindful of time as well. So I want to thank all of our participants for their very active participation and for joining today's Reverse Red webinar. We hope you're leaving inspired, informed, and connected, and that you will collaborate. And I want to extend our special thanks to our host, David Field, and also our speakers, Dr. Carly Cowell, Dr. Amr Sadler, and Dr. Nacho Beatriz, as well as Megan Joyce from the Reverse the Red team for all of the work that she has done leading up to this webinar. So thanks very much. And the recording and the resources associated will be available soon on the Reverse the Red website, so please check it out. And in the meantime, please stay connected, stay hopeful, and we can definitely reverse the red. And I just want to also say that there will be a quick survey at the end of this webinar, so if you want to take it, please do. We will appreciate the feedback. So thank you all, and goodbye for now.